Dr. Alexander Strom, eminent landslide expert and member of International Consortium on Landslides, who is running a summer school on landslides continuously for several years. Many of the experts have got training under him. So he's been dealing with large scale landslides. So he would be chairing this session, and he is also a presenter of this session. So besides him, Dr. V.M. Sharma unfortunately is having some medical problem, could not come. And I would request Professor Santosh Kumar ji, who is our senior most faculty from NIDM, to kindly join him. He will make a presentation on post-disaster needs assessment. And I will also request that this key discussants, Dr. Lakesh Kumar Sinha ji, Director DTRL. I think he got some urgent work to preps, so he cannot join. But any representative from DTRL would be welcome to join on board. Second, Dr. P.K. Champati Ray from IIRS. Shri Mriganka Ghatak ji from Geological Survey of India. Dr. R. Baskar from GJUST University. So all of the discussants can also join on the dais, because then the session is handed over to Dr. Alexander Strom. He can begin with his presentation. Please, all the discussants can also join on the dais. Discussants are Dr. P.K. Champati Ray, Mriganka Ghatak ji, Vijay Dangwal ji, Dr. R. Baskar. So I request chair and all the speakers and discussants to kindly abide by the time to the extent possible.
So, ladies and gentlemen, dear colleagues, we are slightly out of time. So let us start without long introduction. So, did I understand correctly that Dr. Sharma?
He's not here.
He's not here. Okay, then I will.
I'm sorry,
I
sir.
will be the
Just
first.
one mistake I made. Dr.
Yeah.
P.C. Nawani is the chair in the session also, along with the Dr. Alexander Strom. I would request him to kindly come to the dais. Sorry, in a hurry, I forgot to mention his name.
Long time. So,
Long time.
yeah, long time. Glad to see you. So, I think. Should we? I will think. I will.
Go there.
Yeah. So, dear colleagues, there was some misprint in the program. I would make a short presentation, not about climate change, but about catastrophic rockslide dams that are potential source of transboundary disasters. Actually, outburst floods caused by catastrophic breach of large rockslide dams may have much more disastrous effects than a landslide themselves, because they can affect vast areas downstream, and they can devastate entire river valleys, destroying settlements, roads, life lines, and arable lands. Moreover, such outburst floods sometimes they can originate in one country and finally affect another country, causing the cross-border disasters. Several such cross-border catastrophes had occurred in the Central Asia region. For example, in 1966 in Isfaharam-Sai River Basin, and in 1977 and 1998 in Shahimardan River Basins. A landslide breach occurred here in Kyrgyzstan and finally reached densely populated Fergana Valley in Uzbekistan. One example, it is the rockslide dam in the Yashelkul Lake, of the Yashelkul Lake was breached in 1966, and a flood with a peak discharge of about 5,000 cubic meters per second reached Uzbekistan. Much more powerful disasters occurred in China in 1900 and in 2000, when floods caused by the breach of large rockslide dams in the Igong River in Tibet affected the entire valley up to plains in Assam in India, more than 400 kilometers downstream. It is here. One more quite suspicious site was found about 100 kilometers upstream from the 2000 Igong Dam on the 1.5 kilometer high slope. Here we can see the site of the Igong Dam on the, our left, and on our right it is the new site where similar catastrophe can occur in future. It is its view, and you can see the suspicious slope affected by numerous rockfalls and minor slides. More larger scale image, and it can be hypothesized that about 230 million cubic meters of rock can collapse from the slope, forming a dam which might be about 200 meters high, about, if not more, about 4 times higher than the dam formed in 2000 in the same valley 100 kilometers downstream. And dammed lake that could be formed upstream could accumulate more than 2 cubic kilometers of water, and will, besides, it will block the access to the blockage site. Flood that can occur here could be even more powerful than in 2000, whose peak discharge was about 120,000 cubic meters per second immediately downstream the dam, and about 400 kilometers downstream in India, it exceeded 40,000 cubic meters per second. To prevent or to diminish such cross-border disasters, we need to, first, identify sites with evidence of potential large-scale instability. We should organize monitoring and early warning systems on these sites. We should substantiate in the most critical cases the necessity of relevant and economically efficient technical measures preventing accumulation of large amount of water and of the catastrophic outburst flood. Actually, we cannot prevent slope failure of such scale, but we can monitor it, and in some cases we really can build something in advance to prevent the most critical disasters. And one more point which is definitely necessary, we need better cooperation, better connect between scientists, between researchers and practitioners working on both sides of endangered state borders. Thank you very much.
Yeah, friends, all we know about landslide, it's a very dynamic process. Then in Himalaya, when you look at, they are also geodynamically active, seismically sensitive. Now, under these circumstances, we want something to do so that you see there is a reduction of risk in the sliding process. Now, if we look at 25 years, 30 years back, in the same stretch, geology is the same, it has not changed. But because of the development activities, road widening, the landslides are occurring. More new landslides are occurring. Same material, same slope forming material, same geology, but because of the construction activity, triggering effects are there. Rainfall was always there. That part is okay. But then the main triggering effect is the construction activity in a most unscientific way. We see, very recently I had gone to Uttarakhand, from Rishikesh to higher Himalaya, and I was surprised that you see road widening is going on. And I must say that it is a most unscientific way of doing the things. Tomorrow we will face the same problem, what we are talking about. How the mitigation program is going on? Unscientific way. No parameters are there. The material which is forming the slope, we do not know the geotechnical parameters of that. Fine that you see the geological mapping is going on by 1:50,000 scale. It's an information which should be kept aside now. We want detailed maps on 1:10,000, 1:1,000 in different stages. Why? 1:50,000 scale, then we are waiting for the map to come up or to be given at the site. It's not the scientific way of doing the things. In 1:50,000 scale, whatever information we have identified the areas which are susceptible. We should go parallelly, rightly said by Dr. Bhandari. Are we waiting for the catastrophe to happen here? No. So let us see from that point of view. We are not serious about, we are very much theoretical. And when something happens, then there is a rush. There is a time-bound program that you mitigate for the mitigation. It becomes a real difficult task, and my personal experience in the Varnavat landslide mitigation program, where I was the chairman of the technical committee. We did it, but under what circumstances we did it? So let us talk in that way that you see what are the basic requirements? Geotechnical parameters, geological information, engineering geological information is the foremost requirement of the things. Then you just try to analyze it. Without analyzing, we are cutting the slopes. And then we see you are waiting for the catastrophe. This is what I want to say. Please.
Thank you. You see, it is difficult to add something. I completely agree with my colleague. I also want maybe to add that sometimes when decision makers make decision what to construct, They are looking for immediate reduce of cost, immediate economic efficiency, sometimes missing the point that we will have not only to construct something, some lifeline, infrastructure, road and so on, that we must maintain it. Sometimes it might be more efficient to build maybe more expensive, like a tunnel. But with this tunnel, we will forget about any problems on this road that are related to the slopes. And it is important point that we should address to decision makers. And so now I think we should convert to discussant. And we will ask Dr. Lokesh Kumar Sinha.
Professor Santosh Kumar has to make it.
Sorry. I'm sorry. Professor Kumar, welcome.
After that discussion.
Distinguished delegates, the chair, co-chair, my presentation would not be on a very scientific approach, but I would be looking at the impact and effect. That is my concern. When I look at this landslide, especially when I looked at in Kerala, what happened in post-flood, also looking at what is happening in the road construction, which is taking you from here to Himachal in the Shimla, and also living myself in the hills for more than 6 years and being a victim of the landslide, mud flow, how we perceive the entire risk of landslide. So that is my concern when we talk about post-disaster need assessment. The important point is that people who are living at risk, and recently when we saw in Balyanala, even if that road has gone, the mudslide is there, but people are still living there. Government has given warning already that this place is not safe for living, but still people continue to live. So now what is the question in terms of when we are talking 1:50,000 scale, people are having even 1:1 meter scale or 1:2 feet scale. They are seeing it every day. So why it is not taken care of? This is one perception of risk. Second is that people are still living below the kind of a flow where that upper part of that has been opened as a kind of an invitation to the landslide, but people down the stream, they are still living. They are not evacuating and they are waiting for the kind of a forced evacuation there. So in this context, that how many landslides in the country, whether it's happened in the Pune or it happened in Kerala or happened in Barnavat or all those famous landslides which have been focused since morning, and also that international experiences which we have, that how this assessment been made, that how it is affecting and how it will affect in future as well. The compounding of the impact in terms of that immediate economic losses, and also that what would be the effect on the people's life living in that close vicinity. The post-disaster need assessment as a kind of a tool which has been evolved over the years at the global level, started in with the Economic Commission for Latin American countries way back in 1972, but later on developed as a DALA tool, the Disaster Assessment of Loss. And currently, National Institute of Disaster Management has developed this as an Indian kind of a customized tool for the post-disaster need assessment. This is a kind of a tool which can give you an assessment that how we are going to assess the impact of disaster in terms of especially the landslides. Probably that economic of scale has not been worked out in many of the landslides to actually inform or educate the policymakers. Many of the studies might be carried out, but when we were looking at the landslide and leading to what kind of a losses and the impact and effect basis, because this particular tool talks about immediately after the disaster, what kind of a direct damages which has occurred in terms of the infrastructure and the people's life, number one. Number two, also that is a flow of economy, that how it is disrupting the flow of economy in terms of indirect losses. The third is this effect, that what is the total collective loss happen to the individuals, households, that community, environment, and ecological issues. The fourth is this important in terms of impact analysis. Effect will give you the effective analysis of kind of a quantitative assessment of the actual loss, and then finally it comes to the effect, and that effect is that how people are likely to be affected. Like I have seen in the hills also, that you might have seen also at many times, at many occasions, people are getting shifted from one place, they are rehabilitated to another place. Another place is in India is that very typical kind of a resettlement process is taking place, where you are getting shifted from one vulnerable areas to the another vulnerable areas, and then another vulnerable areas to the third vulnerable areas, and that those people kind of a 3 and 4 type of settlement have already taken place, and people are now, they are living with the risk and they have no interest in changing another, because the land dispute is also, your resettlement is happening on the forest land, and that the subject of disaster and the landslide is with the revenue department. So this is a very classic turf battle is also there, and the role definition is there. So when we talk about impact, effect and all, and the last but not the least in terms of the needs, what is the need for the future? Like when we talk about, we make analysis of one landslide, then the second landslide, third landslide, fourth landslides, and collectively when we look at that how we are going to see as a economic impact overall. And when we talk about this, the settlement would be there. It's not that settlement will not be there, because the kind of urbanization pressure is also in the hills of the cities of the hills. It's not happening only on the plains of the areas. If you see, all those areas has been multiplied manifold over the years. And this pressure will continue in the times to come. So by 2030, we are saying 70% of the people will, 50% of the people will migrate to the cities. So additional 20% of the load will come on the hills and the landslide prone areas as well. The cost, the economy would work, where you will go, and that the cost of the safety is much higher. If today you are living in the landslide area, and if you are going to be shifted to another areas, what would be the land cost and where the settlement would be? So accordingly, when we are seeing that transportation, broadening of road and everything, with a large number of population are settling down in the cities, that definitely it requires the supply chain management as well for protecting their livings. They need everything day-to-day life. So that broadening and the prosperity which is happening in the country also in India, especially when we are talking about that people are also going to the hills. The large number of floating populations are also uploading the hills and the press and the mountains. So overall, what I would suggest here as a kind of a post-disaster need assessments tool would be applied, and economics of this landslide should be worked out very clearly, and that would define in terms of the final policy that what kind of a public policy we need in future for protecting the landslides, whether we need scientific study alone, or we need to look at that the social and economic intervention which is happening all together at for the human being who are settled down in the landslide areas, and how to actually provide those solutions where people can live very friendly with the mountains in terms of, or maybe the landslide prone areas. It's not happening on the mountains only, so even the smaller hills happening. And we also should not forget about the avalanche. So that has a bigger cost that to be taken into account when we talk about post-disaster need assessment. So this is a classic tool which can be applied. It's very scientific and very dynamic. So that will give you a kind of an insight to move further. Thank you very much.
Thank you very much for a very interesting presentations and for being strictly on time. So now we should start discussing. Okay, now we should shift to discussions. Considering again lack of time, I will ask discussants to be as precise, as short as possible. So please, Dr. Lokesh Kumar Sinha, Director, Defense Terrain Research Laboratory. Not here, sorry.
Dr. P.K. Champati. There are two persons.
Oh, we have a short, okay. It will make shorter, yeah. Okay, some of our proposed discussants. Yeah, please.
Sorry, I'm taking time because I need to leave for some another assignment which is already going on in the NIDM. I just mentioned 5 quick recommendations to be taken in terms of one, this start understanding PDNA as an assessment tool for the future in planning for landslide mitigation and risk management. Secondly, have a capacity development program integrated with the landslide management for the PDNA. Integration of ex-ante database management from these agencies. Without data, it's not possible to manage this. And design for reallocation should also be looked into the economic of scale. That is important. And incentivizing risk reduction probably would work as a kind of a major tool. Thank you very much for this.
Thank you for your comments and for your suggestions.
I would like to take leave. Thank you.
Thank you. Okay. Now, Dr. Champati Ray, Indian Institute of Remote Sensing. Yes, please, Dr. Ray.
Good afternoon to all of you, Chair, Co-Chair, and the all panelists, and the distinguished delegates, which includes my mentor, Dr. Bhandari, Mr. P.K. Jaina, Secretary, Odisha Government Disaster Management, and many dignitaries who are present here. I'll just briefly touch upon the main points, what we understand about the landslides and its mitigation based on our research of last 3 decades. We are one of the first institute to map landslides, which is the basically fast order information collection using aerospace media way back in late 80s during the Parvati Valley hydroelectric project. The journey we started late 80s, and since we have reached 2019 with latest technology. So what is critical here is that the sum up the things I will sum it up. The technology today exists, and we can reach a zero casualty status in case of the landslides. It's not a tall order claim. The level of technology, the kind of technology what you have today, since morning we have been listening, and I at the Indian Institute of Remote Sensing had the privilege of introducing some of those technology for the first time in the country. Now, before we go into that, I'd like to just inform that the landslide research in this country started as a supply driven. The researchers, geomorphologists, geologists, geographers who had experience, who knew this phenomena in Himalaya, started working and to understand this phenomena. Gradually, over a period of time, it has affected life and property. That's the reason the demand has increased, and it has outspaced the supply in terms of the technology, in terms of particularly the knowledge, the people who can provide the solution. On top of that, we have the confronted with the climate change developmental issues. So that's the main problem, the complex situation. First and foremost thing is that we need to understand the hotspot on the global map, that's the Himalaya, for the landslides. There is the intricate relationship between the climate, tectonics, and erosion that needs to be understood very, very carefully and very thoroughly. And unless we do that, we will be making a effort here and there, but the complete understanding if it is not there, it will not help a very, very sustainable solution at the end. The landslide and development, it has been highlighted by Nawani sir. Society interaction, how do we make our houses, how do we do the cultivation on the hill slopes, and the climate change. you'll be surprised to know that there is an increased precipitation in terms of the rainfall, and each raindrop hits the ground with enormous amount of kinetic energy compared to the snow which was falling before. I am referring to the altitude zone of 2000 to 3000 meter, where normally we get snowfall or beyond snowfall. Now in place of snow, we are getting the rain. This has been already published by the, none other than the IMD and also the MOES secretary about the extreme rainfall events which has increased, and that has changed the dynamics, and it is attributed to the climate change impact. We need to understand that. So in short, what I say that Earth system, how does the Earth work in every mountain system should be understood holistically. Now we have discussed a lot, but my emphasis is on the very, very simple, the people-centric simple landslide hazard mitigation program. Why can't we have that? You must be wondering that, what this simple thing we're talking about. I will elaborate a little later. Can't we use the UAVs and the satellite images to monitor landslides in our neighborhood? Today, UAVs can be, operated by young students to collect lot of information almost real time, but we have not deployed yet, except some few examples where we have done it. For the Balyanala landslide, recently discussion was there, where Indian Remote Sensing has flown the UAV and provided unprecedented details about the landslide and the evacuation plan what the state government has undertaken to contain the effect of the Balyanala landslide. Technology is developed for very high resolution deformation monitoring. Yesterday we had a wonderful presentation by a Swiss agency and the Swiss Development Cooperation, SARMAP and others. They had presented that how precedently centimeter level movement can be detected using space interferometry, satellite interferometry, SAR interferometry. This technology we demonstrated in 2002. But and not only that, the subsurface probing what you saw today, Dr. Kanungo's presentation, below the earth slip surface determination, IRS was the first to introduce. Being a space agency, investing on the ground and on the ground instrumentation and getting the details below the ground, on the surface, above the surface, combining to give a solution. This is unprecedented, and the technology today is there, but unfortunately there are few takers. When you talk about technology, technology is there for all the solutions related to landslides. I must claim that, but unfortunately there are few takers. Now what is that one thing we should do? Landslide early warning system and low cost preventive measures to contain the landslide. I don't dare to use the control. Can you really control the landslide? Mega landslides I am referring to. Who has the technology to control it and at what cost? Can country afford? A single earthquake of 7 magnitude happens, 7 to 8 magnitude, there will be 3,000 landslides. At how much money you will spend at every landslide to control it completely? Strategy is to contain it, live with it, and for that there is an alternate strategy. So what I am trying to say is that can we achieve a zero casualty status to landslides? We have almost done it so in case of cyclone. Filin and the Funny has shown that the death toll of similar cyclone in 1999 was 10,000, and 2019 when you see the similar cyclones, little lesser intensity, death toll has come down to less than 3 digits. So that shows that it is possible and technology is existing and there are expertises are available. So whatever you want, you please suggest and we can strategize. And this part of the information what I'm telling about the early warning system already documented by the NDMA on the landslide and part of the landslide strategy documents. So thank you very much for giving this opportunity, and we are always there to help whoever wants to work on this.
Thank you very much. Thank you very much. Our next discussant is Dr. Ghatak, Director of DGCO, Geological Survey of India.
Good afternoon. Actually, this session, it is something different from the what we have been discussing earlier on. In the previous sessions, they were previously discussing the mechanism, the dynamics of the landslide. But this session, it has given an entry point for something which is very rarely discussed in landslide seminars. That is the PDNA, which brings into focus the economic and the social sector into landslide studies. And I wish Professor Santosh had stayed here, because in some of the earlier occasions we have discussed that this PDNA, how it can incorporate the existing data sets, because the geological information is the base for any landslide studies. So as Dr. Raju and Akshay were earlier highlighting, that there is a lot of data, that seamless data which we have, how that can be a part of PDNA, those kind of things could have been discussed in more detail in one of the other seminars perhaps. But that is a very good entry point for this landslide discussions. Also, we are mostly discussing about the bigger losses and all, but there are indirect, imperceptible losses which are going unnoticed. Let's say, for example, a landslide has happened. So the small transporters or the small scale operators, they have to take a detour route. So what is the losses which is getting involved in that? Those kind of things. Or suppose what mostly goes unnoticed is the slow subsidence zones. There are not very clearly visible to the eye's signatures, like suppose an area is undergoing repeated, it is requiring repeated civil work, restoration work. So there is a logic, there is a background to it. So this smaller kind of signatures, because everybody, everybody wants to study the bigger landslides. Everybody wants to study this Barunabrat. Everybody wants to study this Kalyasur. But new risk profiles are emerging. Take this case of this Assam. The primary risks which were identified were the flood and the earthquakes. But from my experience of this 2015-16, there were a spate of landslides, and not big landslides, small landslides which are happening in urban settlements and in small cut slopes, because the encroachment has been to the non acceptable limit of the cut slopes. And I think smaller groups now need to work on this kind of smaller landslides which are not attaining proper focus, and also to concentrate more studies in urban settlements, because there are certain challenges in urban settings, like the accessibility to the data collection. These are certain challenges which bigger landslides do not offer. So with that, I will end, maybe discuss some of these points may be incorporated in the final recommendation. Thank you very much.
Thank you very much. Thank you very much. And our last discussant, Dr. Baskar, Environmental Science and Engineering Department.
I am told to be brief because I am the last barrier between you and the lunch. I will not take more than a minute. I am a teacher, and since morning I have been observing, I make 2-3 points. One is, I feel the curriculum, after listening, it's only half a day, needs to be revised. Second thing, which my colleague has already touched, there is still a poor understanding about climate change and landslides. They will bring change in precipitation patterns, change in dry spell periods, and there is need for increased research to link climate change to landslides. Maybe the vulnerability maps which we have today will change whenever in future, near future, even in 10 years, there are reports that changes have occurred. The last one I am saying is the practical application, community involvement. As I said, I am a teacher, and I have, every teacher has a lot of students, every university has a lot of students, and we can involve them through NSS or NCC units and train them. NIDM can take the initiative of giving training, and we are having a demographic dividend. We have energetic youth. In times of disasters, they will happily contribute to nation. With these words, I thank all of them for patiently listening, and to Dr. Surya Prakash for inviting me, and all the honorable dignitaries. Thank you.
Thank you very much. Short and sweet.
Thank you.
So, with the permission of the chair, I'll like to conclude the session with our sense of gratitude towards all the chair and discussant as well as the speakers. So I'd request my colleagues to kindly help me I'd request ED and Nidm to kindly give a pot of plants to all the speakers, chairs, and the discussants. Please. A photo, sir. Nawani, sir. Ghatak ji used to work in SDMC, SARC Disaster Management Center. I would request a group photograph of the session and then we'll depart for the lunch. Since we are delayed for the lunch, so we'll start the next session after 45 minutes, right, for the lunch break.